This is lesson 8.4. We're going to talk about the triangle proportionality theorems. So the first one is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the segments into proportional lengths. Not equal, proportional. So that means when we look at the picture like this, the number here will go over the number here. We're going to make a fraction out of the two values on this side, and we'll set it equal to the number here over the number here. BD over DA will equal BE over EC. So visually, we're going to set up our fractions exactly as they appear in the picture. If they turn the triangle sideways, and they have the parallel line going this way, it's okay to make your fractions still as they appear, one over the other as they show up. So really visually, we're just going to make fractions with numbers that appear above each other and set them equal. The converse is also true. If I can show that this fraction on this side is equal to this fraction on this side, then I can show that these lines are parallel. So for example, 1a, I'm just going to take these two numbers, 14 over x equals these two numbers, 12 over 15. Because the lines are parallel, I can do this. So we're going to cross multiply. I get 12x equals 14 times 15, which is 210. And when I divide that by 12, I get x is 17.5. It's okay to get decimals here. It's okay to get gross decimals. It's fine. So example 1b, I have a little bit of a problem first because I don't know what this little chunk is. The whole segment was 55, and the bottom part of that segment was 45. So if I subtract those numbers, I'm really left with 10 for that segment, and now the 55 is gone. So I can make a fraction x over 36 equals the other fraction, 10 over 45. So cross multiplying, we're going to have 45 times x is 45x, and 36 times 10 is 360. So when I divide 360 by 45, I get x is 8. One more together. Again, 30 over the x plus 7 will equal 25 over the 15. We just have to remember to stick parentheses around our x plus 7. So when we cross multiply, it's going to be 25 times all of x plus 7 equals 30 times 15. So that'll be, when we distribute, 25 times x is 25x. And then 25 times 7 is 175. And then our 30 times 15 is 450. Let's minus 175 from both sides. So 25x equals 275. And now when we divide by 25, we get x equals 11. So there's going to be a series of check-ins for you to try. I would pause and check my answers on Google Classroom. So this is check-in number 1A. This is check-in number 1B. And this is check-in 1C. For example 2A, we're going to determine if the lines are parallel. So we're going to make the fractions and see if they're equal. Again, like before, I don't know this little chunk right yet. I know the whole thing is 54 and the one piece is 24. So if I subtract them, I get 30, and now that 54 is gone. So making my fraction, it's going to be 30 over 24. And making this fraction, it's going to be 37.5 over 30. I can reduce both. 30 divided by 24 is 1.25. 37.5 divided by 30 is 1.25. So that's equal. So this answer is yes. I need to show this work before I can give an answer of yes. And if I was really explaining it, I would say yes because the sides are broken up proportionally. Here's example 2b. So let's try it again. I'm going to take the 15 over the 18. I'm going to take the 4 over the 5. So 15 divided by 18 is 0.83 repeating. And 4 divided by 5 is just 0.8. So these are not equal. So no, the line is not parallel. Here's one for you to try. Pause. The answer is posted on Google Classroom. Extending the triangle proportionality theorem is the proportional parts and parallel lines. So if I have 3 or more parallel lines intersecting 2 transversals, whether it's in a triangle or just 2 random lines, then they cut off the transversals proportionally. So if I have the 3 or more parallel lines, then the little chunks in here are also going to make fractions that are equal. So we're going to treat this the same as if these 2 lines had connected and made a triangle. We're still going to make the fractions visually how they appear in the shape. So for example 3a, we know the whole thing is 32. We need to know this little chunk. So 32 minus 18 is 14. So now my fractions, the 27 can go over the 18 equals the x can go over the 14. So when we cross multiply, we get 18x equals 378 when I multiply 27 by 14. And when we divide by 18, I get x is 21. Example 3b, 2x plus 2 can go over 21, and then x plus 3 can go over 12. And I'm going to put parentheses around them so I remember to distribute. So it's going to be 12 times 2x plus 2 on one side and 21 times x plus 3 on the other side. We're going to make sure we're distributing. So this is going to be 24x plus 24 equals 21x plus 63. Take away 21x, we get 3x plus 24 equals 63. If we minus the 24 from both sides, 3x equals 39. And if we divide by 3, x is 13. There are 2 last problems for you to try. I would pause now for check-in 3a. And then we have check-in 3b. Answers are posted on Google Classroom. And that's the end of section 8.4.